Hello and welcome back to another Algebra 1 video brought to you by Mr. Slagle's Mathnasium. Today, we are going to be solving systems with a new method called elimination. We have seen graphing and substitution previously. In graphing, remember, we graphed both lines and the solution to the system was where the two lines cross. In substitution, we isolate a variable and then we take that resulting equation and substitute it into the opposite equation. Now, when we learned graphing, sometimes if the lines didn't cross directly on a grid line, we had to estimate what the solution was. With substitution, we got an exact answer. Turns out, with elimination, you also can get an exact answer, which is why it is a great technique as well. So why should we learn elimination and substitution? Why not just learn one? Well, it turns out that there are certain systems where it's easier for us to solve using elimination. There are certain systems where it's maybe a little easier for us to solve using substitution. Makes more sense. So, without further ado, let's go ahead and see the rule that we're going to use throughout this lesson and jump right into solving our first system. Hooray! Okay, the rule is we can add and subtract equations just like we can with expressions. So let's see our first example. Our first system is 5x minus 6y equals negative 32, and 6y plus 3x equals 48. Now, graphing these doesn't look very nice. We'd have to maybe put them in slope-intercept form, which would probably involve lots of fractions. It's going to be pretty ugly. We could find x and y intercepts and graph, but I don't really feel like doing that. Substitution, also tough. It turns out it's not super hard to solve for x in this equation, so that wouldn't be too hard. But there's this other method that's going to be a lot easier. So basically, this is what you do to solve a system of equations. Solve a system of equations using elimination. What you do is you take the second equation and you are going to write it, or you rearrange the equations so that they are displayed, the terms are displayed in the same order. This one goes x term, y term, equal sign, constant. So that's what we're going to have to do to the red equation. So I'm going to rewrite this as x term, that's a positive 6y. So y term, x term, y term, equals, and our constant. So we had to do a little rearranging there. That's okay. So we're allowed to add in different orders. That's fine. 3 plus 5 is the same as 5 plus 3, so I put the 3x plus 6y, I put the 3x first. So now what we can do, you'll notice that I am able to add the equations. Now that they are in the same, they're in the same order, we can kind of add the like terms here. So that's what we're going to do. So we're going to do 5x plus 3x gives us 8x. Now, I just chose subtract and I'm using purple. That's okay. So 5x plus 3x gives me 8x. Negative 6y plus 6y gives me 0. And negative 32 plus 48 gives me 16. So you can choose either addition or subtraction. I chose addition because that is the operation that will eliminate the y term, because they both have roughly the same magnitude. They both have a similar coefficient. They're both the same. Another way to say that would be their coefficients have the same absolute value. So we can solve this equation further. 8x equals 16, divide both sides by 8 to get x equals 2. Let's continue solving our system. So we've found x. Oh, sorry team, just about died. Okay, now I'm going to take that x and I'm going to plug it into the top equation. That'll be 5 times 2 minus 6y equals negative 32. 10 minus 6y equals negative 32. Okay, subtract 10 from both sides. minus 10, minus 10. We get negative 6y equals negative 42. So y equals 7. So where do our two lines cross? Divide both sides by negative 6. Two lines cross at 2, 7. So what are the steps that we used to solve our system? So step 1 is line up like terms in both equations. Okay, that's what we did right here. So we made sure that x was under x, y was under y. The second thing, which we really didn't have to worry about because it was already done for us, is, and this is the rules that I'm going to be following for the rest of the problems, is make one set of like terms. So we can eliminate the variable. You want to get the coefficients of one variable the same. And when I say the same, I'm saying like they could both be 6, or one could be 6 and negative 6. We want them the same magnitude. We want them the same absolute value. So that was already done for us. These were both 6s, so we were good. And then the third step is you add or subtract. And it's really important that that you're using these parentheses. When you have a minus sign, we'll get to one that looks like that here in just a minute. So those are the 3 steps that we're going to use to solve systems. And now I'm just going to do a bunch of problems. If you think you've got it and you want to try one, be my guest. So let's jump right into it. Okay, so here's the first one. When I'm looking at this, the first step is make sure our terms are lined up. Let's see. Okay, x lined up with x, y lined up with y, equal sign lines up, constants line up. So that means I have to choose an operation that I'm going to use. Change my color. All right, so I want to get one of them to go away. These two are already the same absolute value. The coefficients are both 2. So you have to think, is 2 plus 2 going to get it to go away, or 2 minus 2? So we're going to subtract. 2 minus 2 gives us 0x. And then we got to think negative 3 minus y. It's negative 4y. And 61 minus negative 7 is 68. So please make sure you realize you're really kind of distributing this minus sign to every single thing that's in the equation. So it's kind of going all over the place. Okay, so this is really going to turn to positive. This is going to be negative, and this will be negative. The common mistake on this question is people don't add those parentheses, and so they just change the first term. Or they add the parentheses, they put the minus sign, and they still just add. So please be careful and make sure you're visiting the sign between each term. So 2 minus 2x minus 2x, negative 3y minus y, 61 minus negative 7, which is really 61 plus 7. Okay, so now we want to divide both sides by negative 4. So we'll get y equals, and then we got to figure out what 68 divided by 4 is. 1, 4, subtract 2, 8, 17. So y is equal to negative 17. Okay, great. So I'm going to plug this back into one of the two equations. It doesn't matter. We'll do the bottom one because it seems like the numbers are a little bit simpler. Plus negative 17 equals negative 7. So that's 2x minus 17 equals negative 7. Add 17 to both sides, which will give us 2x equals 10. And x equals 5. So we have solved the system. These two lines cross at 5 comma negative 17. Woohoo! That's our solution. Now let's keep going. All right, you guys probably have the ability to try this one, so if you want to pause the video and give it a shot. In the last one, we eliminated x. In the one before that, we eliminated y. What variable is going to get eliminated here? Give it a shot. Okay, here we go. Let's see. Everything's lined up. So we actually, so everything's lined up, and these two have the same absolute value. So that means we can subtract. So 2 minus 4 gives us negative 2x. 18 minus 18 gives us 0. And then over here we have negative 9, might help to write it out. Negative 9 minus negative 27, which is negative 9 plus 27. If it's hard to keep track of that in your head, don't try and do it in your head, which gives us 18. All right? So now solving this, divide both sides by 2, we'll get x equals negative 9. Fantastic. That is so much easier than trying to do it by substitution. We just line these up, subtract, things go away, and we're good to go. Things are eliminated. They get Hulk smashed. So I'm going to plug x into the top equation. So that'll be 2 times negative 9 plus 18y equals negative 9. Negative 18 plus 18y equals negative 9. Add 18 to both sides, and you'll get 18y equals negative 9 plus 18 is 9. Divide by 18. Y is 9 over 18, which simplifies to 1/2. All right, so our solution is negative 9 comma 1/2. And that's one where graphing might be a little difficult. You'll never be sure, you know, it's hard to be sure that it actually crosses at that perfectly at 1/2. Okay, great. Let's keep cruising. All right, so this one, step 1 is not, we have to do some rearranging, right? Things are out of order. This top equation says 2x plus y equals 8. The bottom equation says 2x minus 8 equals negative y. So this is x, y equation constant. This is x constant equation y. So what we're going to need to do in this bottom equation, the first thing I'm going to do is add y to both sides to get things into good shape here. So it'll be 2x plus y minus 8 equals 0. And then I'll add 8 to both sides to get 2x plus y equals 8. Now we're going to rewrite the system, and you probably have already noticed that the top equation and the bottom equation are the same. So when we go to subtract to eliminate a variable, we end up eliminating both variables, and you'll get 0 equals 0. 2 minus 2 is 0, y minus y is 0, 8 minus 8 is 0. Since this is a true statement, and since our lines are the same, that means there are infinite solutions. They are the same line. Cool. All right, now this is where we start ramping it up a little bit. So with this one, everything's in the correct order. It goes x, y equal sign constant, and both of them are in that order. The problem is I can't just add or subtract to eliminate one of the variables. Aha! But we also learned that in our first unit that we can multiply both sides of an equation. We can do anything to one side of an equation as long as we do it to the other. So I'm going to multiply the left and the right side by 5. Now the reason I selected 5 is because we're going to rewrite our system, including the one that doesn't change. So this bottom one does not change at all. I want you to rewrite that as well. Okay, so up here in the top, we're distributing 5 to both of those terms, like so. Okay, and so what that does is we've treated both sides equally, so it still represents the same equation. So this will be 5 times 2 is 10x. This will be 5 times 5 is plus 25y equals negative 22 times 5. Well, 5 times 20 is 100, and 5 times 2 is 10. Add those together, negative 110. So yeah, so now we could subtract and go forward. If you're worried about, so now the x's can be eliminated because they have the same coefficient, right? If you're worried about the subtraction rule and you're worried about like, oh my gosh, I'm going to forget to change the sign, I'm going to screw that up, There's another trick that you can do that might help you out. Instead of multiplying by 5, since we can multiply by whatever we want, we could multiply by -5. That would make this -10, this -25, and this +110. How does that help us? Well, let's take a look. Now, instead of subtracting, we add, and we don't have to worry about changing the signs anymore because we've already changed the signs and we multiplied by a negative number. So let's go ahead and go through. -10 plus 10 is 0. -25 plus 3 is -22. Y equals 132. So when we divide both sides here, I think this is 6. So that'll be -6. Y equals -6. So you would probably use a calculator. For that, I had to when I did it the first time today. So 132 divided by 22 gives us -6. I never meant to memorize my 22s on the multiplication chart, apparently. Really was slacking when I was in elementary school, I guess. All right, so let's plug -6 into the bottom, I guess. 10x plus 3 times -6 equals 22. 10x minus 18 equals 22. So 10x equals, add 18 to both sides, 10x equals 40, and x equals 4. So where do our two lines cross? 4, comma, -6. Great. All right, and here's the last one that that's new information. We will have a couple more ones for you to practice and try. All right, so let's take a look. Everything's in the correct order, so that's great. The issue is that I can't multiply 8 by anything to make it 10, and I can't multiply 6 by anything to make it 8, or at least a whole number. So what can we do here? How do we get these two things the same? So basically, when you're in this scenario where you have, I can't multiply and scale these up, it's exactly the same scenario as when you have two fractions with different denominators that you want to add. You have to change both of them to get them to the same spot, where you have to multiply both of them by something. And it turns out that something that we multiply is the least common multiple. So I'm going to eliminate x, so I'm just going to pick x. So we're going to find the LCM, the least common multiple, of 10 and 8. And the way that you do that is you write out the multiples of each number until you write the first number. You want to find the first number that's in both lists, or easy way to do that is work up the bigger number list, find the first number that's divisible by the smaller number. And of course, if I continue, 40 will be our least common multiple. So we're going to find the least common multiple of these, which means I want to turn this term into 40. So what I'm going to do, so in the last one, the LCM of 2 and 10 is 10, right? So it's the same process, it's just we can see that if I just multiply this one equation, we're good. Here we have to multiply two equations. So I'm going to multiply the top equation by 4 to make the first term 40, and I'm going to multiply the bottom equation by 5 to make the first term 40. We want to get them to be the same. So my new top equation is going to be 40x distributing 4 times 8 gives us plus 32y equals 8. The bottom equation will be 40x plus 30y equals 5. So I've multiplied all these terms by 5, all these terms by 4. We can now subtract. 40 minus 40 is 0, 32 minus 30 is 2y, and 8 minus 5 is 3. So y is equal to 2/3. That's gross. That's really gross. That's okay. So let's go ahead and plug this in. Oh, sorry, that's not right. It's 3/2. Aha! I was testing you. It's 3/2. Slagle did the old switcheroo. Divide both sides by 2. That's what I get for skipping steps. Now we're going to plug that in. I'm going to use the bottom equation. 8x plus 6 times, 3 halves, by the way, is 1.5. So if you want to keep things simple, equals 1. 1.5 of 6. Well, half of 6 is 3, so add that to a whole 6 and you get 9. This is 8x plus 9 equals 1. Subtract 9, 8x equals negative 8. So x equals negative 1. There's our solution. Now, let's think about for a second what this would look like with substitution. If you're like, I'd rather use substitution. Well, it's really pretty ugly. So you would have to get 8 to the other side. You end up with this just absolutely awful. Let's say we want to substitute, we want to solve for y in the bottom equation. You'd end up with y equals negative 8x plus 1. Okay, this is why elimination is better. Divide by 6, and you end up with, yikes, forget that. Divide by 6, negative 4 over 3x plus 1/6, and then I have to take that and plug that into the top equation. No, thank you. Yeah, that's rough. So that's why substitution is maybe the not the best choice here. So let's recap our strategies. What do we use these three for? Graphing is used for maybe like estimating where the solution is. You know, using a graph can be very, very helpful to finding a solution for a system of equations. Substitution is great when you already have a variable isolated. So if one of the systems is like y equals 3x minus 9, and the other system is like 3x plus y, or 2y equals 12, and you want to solve this, well, it's really easy for us to just put that in there, distribute, and solve the equation. That can go very fast. We don't need to rearrange anything. It's ready to go. So substitution is great when a variable is isolated for. Elimination is great when we notice that two of the coefficients are the same, or that we can scale one equation, or both equations, to make the coefficients the same. So that's kind of the strategy behind those. So I got two problems for you that I want you to try. I'm going to do this in layers, so if you want to try it right now, go for it. I'm going to give you a little hint. If you can't get it from the very beginning, go to the hint and watch that, and then try and work through it. If you can't get that, just incrementally work your way forward. So first things first, so you should go ahead and pause the video if you're wanting to try this on your own. Okay, first things first, the terms aren't lined up. This is x, y equals, and then 6 in our constant. This is x equals y and then our constant. So the equal sign is not in the same location. So that means I'm going to have to rewrite my system. 4y equals 16. And the way that I'm going to do that is by moving 4y to the other side of the equation, which will be 3x minus 4y equals 2. So here is my system that I need to solve. And we still have a problem. The problem is that I can't subtract. So everything's lined up. It's x, y equals constant. Everything is lined up, but I'm going to have to scale the bottom equation. Now, there are lots of ways to do this to get the variables to be the same. The bottom equation, I think, is the easiest one. Simply multiplying this by 2 will give us a resulting system that we can add or subtract to cancel. So let's do that. It'll be 4x plus 8y. This one doesn't change. By the way, please recopy the whole system each time you change something. This will be 6x minus 8y equals 4. Other options, you could have changed both x and y, so multiplied the top by 3, the bottom by 4. That's more work. You also could have multiplied the top by 1/2, which would be 2x plus 4y equals 8, and then the 4's would cancel, so it's up to you. Whoop, I got a visitor, hold on. All right, we're back in action. All right, so let's go ahead and continue solving here. Here we go. All right, so we multiplied the bottom equation by 2, And now we're going to select an operation, either addition or subtraction, which is the one that eliminates the two terms with the same coefficient. It would be addition because they are already different. So we're going to do 4 plus 6 gives us 10x equals 20, so x equals 2. And plug that baby in. I'll do the top one. 4 times 2 plus 8y equals 16. 8 plus 8y equals 16. Take that, computer. Subtract 8 from both sides. 8y equals 8. Y equals 1. So our solution is 2, 1. All right. And here's another one for you. You can try this one on your own, or wait. So here we go. This one's actually going to be pretty fast. All right, so everything's lined up. We're good to go. We need to multiply the top by 2 to eliminate x, which will result in the system 6x plus 2y equals 16. Okay, and then on the bottom is 6x plus 2y equals -2. And so if we want to eliminate x or y, we would need to subtract. The problem here is since they're both the same, 6 minus 6 is 0, 2 minus 2 is 0, you end up with 0 equals 16 minus -2, 16 plus 2, which is 18. It wouldn't matter if we added or subtracted there because either way we get a false statement. And I guess that's not our answer. Our answer here is no solution. So if you end up doing elimination, you get a false statement. The answer is no solution, which means these two lines are parallel. They have the same slope at different y-intercepts. Okay, and that's it. Your assignment will be in My Open Math. Hope that was helpful. I hope you understood how to do elimination, and I hope that you have a good time practicing this on My Open Math. See you next time.